Moving heavy loads with slings, chains, and hoists is a technically demanding job that requires great care. Safety is one of the most important parts of any rigging operation. On any rigging job, there's one person in charge. He's got to plan the job, inspect the equipment, and make sure the equipment's used safely. You've already learned quite a bit about rigging and rigging safety. We've discussed planning the job. We've seen the equipment and how it works, and what to look for when it's inspected. We've also talked about safety gear for rigging. Hard hats, gloves, and safety shoes are the very minimum you'll need. What we're going to do now is put all these pieces together. We're going to follow a rigging job from start to finish and see how the whole operation works. We'll watch as this rigger plans the job. We'll see him inspect the equipment, attach the rigging, and we'll watch as the load's picked up and moved to its new location. The first thing we're going to talk about is planning the job. You'll remember that the 4 basic steps in planning any rigging job are finding the weight, checking the balance of the load, making sure you've got room to move the load, and selecting the equipment. Let's go through these steps one at a time. Norris is responsible for getting this unit moved to the floor below for installation. The first thing he's going to do is size up the job by finding the weight of the load. One place to find the weight is on an equipment nameplate. But unfortunately, this pump and motor assembly doesn't have a nameplate that lists the total weight. Since he can't find the weight listed right on the load, he turns to another source of information, the equipment manual. It lists the weight of the unit as 650 pounds. If he didn't have this listing, he could look at the shipping papers or estimate the weight of the load by comparing its size to that of a similar piece of equipment whose weight is known. After finding the weight, Norris estimates the balance of the load. Experience has shown that the pump will be the heaviest part of the load. As he eyeballs his sling lengths, he figures that the balance point will be off-center, closer to the pump. If the load's picked up from the center, it'll tilt. To level the load, the main load hook has to be directly over the center of gravity. For this load, it's convenient to use 3 slings, but 2 of the legs must be shortened to adjust the balance of the load. Norris decides to use turnbuckles to adjust the lengths of the slings. It's not so great an adjustment that he'll have to use a load leveler. Since the pump is the heavy end, the hook will have to be closer to that side of the load. The 2 slings on the pump end will have to be shorter than the single sling attached to the motor. Now that Norris has found the weight of the load and estimated its balance, he's ready for the next step. Where's the load going? First, the pump and motor unit will be picked up from its present position. Attached to an overhead crane, it will travel down a narrow corridor. Once out on the floor, it will have to turn several corners to avoid obstacles. Once the load is in the right position, it'll be lowered down a shaft to the floor below. A hoist is attached to the overhead crane so the load can be lowered slowly and precisely through the shaft. What Norris has to check now are clearances. To see if the load will fit through the route he's planned, he measures the load carefully. First, he measures the width. That will tell him the size of the smallest corridor the load will fit through. Next, to make sure the load is short enough to fit through the shaft, he measures the unit's length. When he has all the dimensions of the load, he's ready for the next step, checking clearances along the way. Norris plans to take the load through this narrow space to avoid having to lift the load over the top of anything. He measures the width of the corridor at its smallest point. It's just barely wide enough, so he'll be able to maneuver the load while it's close to the floor, even if it is tight. The last thing he has to measure is the shaft clearance. The load will have to fit through the shaftway without banging against any of the sides. First, he measures the length of the shaft. It's more than long enough for the load. There'll be about a foot on either side. Next, he measures the width of the shaft. Although the shaft won't be especially tight, it's close enough that extra care will have to be taken when the load is being lowered to the floor below. There's one more thing Norris has to do before he can begin selecting his equipment. Since an open shaft will be a hazard to other workers on the floor, it has to be surrounded with safety cones or barriers before the grating is removed. Before he can start the job, he has to figure the correct number of cones and place them around the opening, allowing plenty of room for him and his crew to work. Now, he has all the information he needs to plan the job. He knows the weight and balance of the load, and he's checked his clearances, so he's ready to decide just what equipment he's going to need. Let's start from the bottom up. The load will be picked up from these 3 eyes. Each eye will need a shackle, so we can attach the next piece of equipment. Norris has already decided to use a 3-legged sling with 2 turnbuckles to balance the load. Its 3 legs attached to the shackles on the eyes. Next comes a hoist, so the load can be lowered slowly through the shaft opening, where clearances are fairly tight. The whole assembly attaches to the load hook of the overhead crane with a wire rope sling and a shackle. The overhead crane provides the travel to take the load where it has to go. The rigging will have to support 650 pounds. To be on the safe side, Norris figures in an extra safety margin even though the rated capacity of each piece includes a safety factor already. Once he's completed his list of materials, Norris goes to the tool room and draws the equipment. Each piece has been carefully checked by the tool room man, but that doesn't mean he won't check it again. He'll double check everything before he mounts a single piece. In a few minutes, we'll be back to watch the inspection. But first, let's review what we know about planning a rigging job. First, find the weight of the load. Every piece of equipment has to be rated at least that high. Second, estimate the balance of the load. If the load must be leveled, you'll need an adjuster of some kind. Third, check clearances. It's awfully embarrassing to get stuck because you didn't measure the tight places along the way. The fourth and last step in planning any rigging job is selection of the equipment. Once you know the weight of the load, its balance, and the clearances you have to work with, you know what your equipment has to be able to do. But it never hurts to add that extra margin of safety. While Norris has the rigging equipment taken to the job site, we're going to pause briefly so you can read section 1 of your text and work the exercises. When we return, we'll be taking a detailed look at the inspection procedure, and we'll watch Norris go to work preparing for the job. Preparing for the job is the next step in our rigging demonstration. So far, we've watched as Norris planned the job. He found the weight of the load, estimated its balance, made sure he had room to move the load, and selected the necessary equipment. So there are really only 2 more things he has to do before he can mount the rigging on the load. He has to inspect the equipment and organize his crew. We're going to start with the inspection process. Now you'll notice that Norris uses a checklist. That way he keeps an accurate record of the condition of each piece of rigging. And he can be sure he hasn't missed anything before he actually rigs the job. The first thing he has to check is the condition of the eye bolts. These are shoulder-type eye bolts. He checks the pins for straightness, inspects the threads, and makes sure the eyes haven't been stretched or cracked by overloading. After inspecting both eye bolts, he marks them off as okay on his checklist. The next item is shackles. He'll need 7 of them. As he inspects each shackle, he checks the shape of the shackle body. Overloaded shackles may look stretched and pinched together. Next, he unscrews the pin. It moves freely without binding. If it was binding, Norris would suspect that either the pin was bent or its threads had been damaged. A close inspection of the threads shows them to be in good shape. No damage. Both eyes are round, and no cracks are visible. After inspecting each shackle, he moves on to the next item on his list, turnbuckles. Norris checks each turnbuckle's body for cracks or bending that might mean that the piece had been overstressed on some earlier job. Then he checks the action of the screws, looking at the threads to see if they're stretched or stripped. Finally, he inspects the eyes on the screws. They appear to be undamaged, no cracks or wear, and they haven't been bent, so one more item can be marked off on the checklist. The next part of the inspection is inspecting the slings. Wire rope slings have to be checked for several kinds of damage: kinks, unraveling, and broken wires. Shiny flat spots on the rope would indicate places where it's been crushed or badly worn. Both eyes should be checked to assure they haven't been kinked when too heavy a load was put on the sling. Measuring the diameter of the rope is a good way to see if the sling's been overstressed. Measurements should be taken at several points along the length of the rope. If the diameter is less than 90% of that of a new rope, don't use the sling. It's been stretched by overloading and is no longer safe. These slings measure the same as a new rope. They've never been misused. After checking all 4 slings, Morris is almost at the end of his checklist. Only one more item remains: the hoist. On any chain hoist, there are 4 things that have to be checked before every use: the top hook, the load hook, the chain, and the mechanism itself. Both hooks are inspected for the same kinds of possible damage: cracking and spreading. Norris has a gauge for this hoist that makes his job easier. His shop has made one for each kind of hoist they use, and each one is marked to identify the make of the hoist and its capacity. He uses the large end of the gauge to check the hook for spreading. It tells him that the hook is all right. It barely drags on either side of the throat as it's inserted. A gap of 1/8 of an inch or more would be a sign of overloading. The small end of the gauge is used to check the load chain for stretch. When it's inserted between links, only the smallest part of the gauge should be able to enter. If the gauge enters farther than that, the hoist needs repairs. It should be reported to a supervisor. Norris completes the chain inspection by examining the links for cracks, wear, broken welds, and finally, the anchor bolt. Once he's convinced that the chain is in good shape, he can turn his attention to the other working parts of the hoist. The hand chain moves smoothly and easily. If it didn't, it would be a sign of damaged internal parts or not enough lubrication. Either problem would be enough to warrant removing the hoist from service. Now Norris has inspected all the equipment he needs for his part of the job. He checked the eye bolts, the shackles, the turnbuckles, the slings, and the hoist. The overhead crane will be carefully inspected by its operator. On some of your rigging jobs, though, you're likely to need equipment that Norris didn't have to bother with. For example, you might be using nylon slings or a load leveler. If you're using nylon slings, inspect them along their length for cuts or excessive wear. On this kind of sling, nylon fibers of a darker color are embedded in the material to indicate worn places on the sling. Where the material is worn especially thin, the darker colored fibers will show up on the surface. There are 4 things to check on a load leveler: the hooks, the chain, the mechanism inside, and the eye on the top of the casing. These are the same things you check on a hoist or a come-along. First, inspect the hooks for cracks. They're likely to occur along the inner surface of the shank. Next, check the hook for spreading. If you don't have a gauge, measure the opening with a rule. Find the size of the new hook by looking in a rigging handbook. Then compare your measurement to that figure. If your hook is spread more than 15%, it's not safe to use. Next, inspect the chain. Check the links for cracks, broken welds, and worn spots. If any one link is damaged, the whole chain's no good. Overloading will damage every link, but you can't always see the result. Finally, check the chain for stretch. One way is to use a gauge, as we saw before. Now, if you don't have a gauge, measure the length of a 5-link section. Compare this measurement to the nominal figure given in a rigging handbook. If it's within 10%, the chain is okay to use. The next part of the inspection is to check the action of the internal parts. The hex adjuster should rotate the sheaves smoothly in either direction. If it's hard to move, it's time to take the load leveler in for repairs or lubrication. Now here's the last thing to check. The eye on the top of the casing, here. The telltale signs of overloading would be cracks or stretching of the eye. If there's no damage, the load leveler is ready to use. Every piece of rigging equipment has to be thoroughly inspected before use. That's the first part of preparing for any rigging job. The second part of preparing for a job is organizing the crew. Let's listen as Norris assigns positions to his crew.
Okay guys, we got to lower fuel oil booster pump from here on elevation 43 down on 29. We'll be over there by the high pressure heater. So it's going to be pretty close when we set it down on that foundation. So you guys are going to have to signal me from down there. And then I'll in turn signal the crane operator. John?
As Norris assigns positions to each of the men on his crew, he's careful to make sure they understand the entire job as well as their own part in it. He rehearses signals with the crane operator so there'll be no last-minute surprises on the floor. When he's finished, he asks for questions. The last thing he wants is for someone to get hurt by not knowing what to expect. We've been talking about preparing for a rigging job. We've watched as Norris inspected his equipment and organized his crew. All these preparations really add up to one thing: safety. And safety will be your greatest concern on any rigging job. In a few minutes, we'll be back as the crew rigs the load for lifting, and we'll see the safety precautions involved in attaching the equipment to the load. Meanwhile, take this opportunity to look through section 2 of your text and work the exercises. So far, we've followed a rigging job through its first 2 stages: planning the job and inspecting the equipment. What we're going to see now is the 3rd step: mounting the rigging on the load. When we left off, Norris was getting his crew into position. To refresh our memories, let's take a look at the basic plan. First, the overhead crane will be maneuvered into position above the load. Then eye bolts will be screwed into the bed plate. Turnbuckles attached to the eyes on the end of the unit nearest the pump. They're connected to 2 shorter slings, while a 3rd sling attaches to an eye bolt on the motor housing. All 3 slings are suspended from a chain hoist that's attached to the load hook of the crane. Let's watch as Norris gets the job started. The first thing he has to do is get the crane into position. This is a signal for travel. A standard set of signals must be used in all crane operations. When the hook is approximately above the load, Norris signals lower the hook. When it's low enough, he signals stop. Now it's time to mount the rigging on the load. The first pieces are eye bolts. Shoulder-type eye bolts are used because the strain will be at an angle to the shank. 2 eye bolts go into the corners of the bed plate nearest the pump. Holes have already been drilled into the metal for just this purpose. Washers and nuts secure the eye bolts to the plate. Both eye bolts are installed so that the slings will pull at an angle in the same plane as the eye. If eye bolts were installed this way, the force would be concentrated at the top of the eye, causing even the best eye bolt to bend. This eye bolt is permanently installed on a motor. A shackle connects it to the first of the slings. Next comes the turnbuckles. They'll be used to adjust the lengths of the slings on the other end of the load. Shackles attach each turnbuckle to its eye bolt on the corner of the bed plate. The other ends of the turnbuckles are attached to wire rope slings. Again, shackles are used to make the connection. Shackle pins should always be tightened firmly, but hand tight is good enough. a wrench shouldn't be needed. While Norris and his helper attach the third sling, let's pause and see how far he's come already. Slings, turnbuckles, eye bolts, and shackles are already in place. Only one more thing's needed: a hoist. The hoist is hung from a sling and shackle connected to the load hook of the overhead crane. Norris is using a hoist for this job because he has tight clearances, both where the load is being picked up and where it's to be lowered through the shaft. The hoist will enable him to control the lifting and lowering of the load more slowly and precisely than would be possible with the overhead crane alone. Once the hoist is in place, he signals the crane operator to raise the hook. When the load hook of the hoist is high enough, he connects the first sling. Then he attaches the other two slings right beside it. In this case, Norris has hung all three slings directly on the load hook. While there's no problem doing it this way, an alternate method is frequently used. When more than two slings are connected to a single hook, a shackle may be used for the connection. This keeps the slings from rubbing together when they're crowded on a hook and prevents wear on the eyes of the slings. Now that all the rigging has been mounted on the unit, the turnbuckles are adjusted to the rough positions necessary to balance the load. As he takes up slack, the legs are adjusted for equal tension. When they're correctly adjusted, the load hook will be directly over the point Norris estimated as the load's center of gravity. While Norris completes his balancing act, let's consider some of the other possible techniques for rigging the same load. Here's one alternative. He could have used 4 slings instead of 3. Except for the extra equipment, 4 legs are no different than 3, as long as 2 turnbuckles are included for balancing the load. However, turnbuckles aren't the only way to adjust the length of a sling. He could use a load leveler. The lengths of each leg can be adjusted to change the position of the load hook. A load leveler can be hung from the load hook of the hoist. Then each of its legs can be used as a chain sling to attach to the shackles on the load. This is a 2-leg rig, so it'll naturally be slightly less stable than a 3 or 4-leg rig. Whenever hooks are used on an angled sling like this, make sure they're placed where they're open sides pointing out. That way, they're much less likely to slip off the shackles if there's slack in the sling when landing the load. As the load's raised, it comes up off balance. To correct the load's tilt, the hex adjuster on the casing is turned with a wrench. As the hex head is turned, the worm and roller gear inside the load leveler slowly pull the chain through the casing. When the load's level, it's ready to be moved. As you've seen, there are many different ways to rig loads for lifting. Often, a single load can be lifted with any of several kinds of rigs. So far, we've seen the same load lifted 3 ways: with 3 slings and 2 turnbuckles, with 4 slings and 2 turnbuckles, and as a 2-legged rig with a load leveler. But as far as Norris's main rigging job is concerned, when we left off, he'd leveled the load and was ready to lift. In a minute or two, we'll return to watch the trickiest part of the job: moving the load. But before we go on, take this time to study segment 3 of your text and work the exercises. Moving a load from one place to another is what rigging is all about. Everything we've seen so far was aimed at picking up a load and taking it somewhere else. Planning the job was the first part of the operation. That's when weight, balance, and clearance were determined. Inspecting the equipment was the second stage of the job. And finally, we watched as the rigging was connected to the load. When we left off, the unit had been lifted off the floor and balanced. In a minute, we'll watch Norris and his crew move the load to its new location. But first, let's get a good look at where we're going. The load starts here, between 2 rows of equipment stands. First, it'll be lifted with the hoist. Then, following signals, the overhead crane will travel while the load is steadied by the riggers on the floor. After turning several corners, the load will be directly over the shaft. Here, it'll be lowered down through the floor to a lower elevation in the plant. Since clearances are fairly tight, the hoist is used to lower the unit through the opening. The overhead crane may not move slowly enough for this critical part of the operation. Placement of the crew is very important for this job. Along the way, visibility will be limited. Every crew member has to know his part of the job and know the signals used for crane operations. Norris and one helper will guide the load as it travels above the floor. The man giving the signals will be in full view of the crane operator at all times. 2 men are stationed on the lower level to guide the load as it's set down. Their signals will be relayed to the crane operator by one of the men above. With this in mind, let's watch the crew move the load. The object here is to keep the load low, steady it by hand, and keep it from bumping into any of the equipment nearby. Norris's signal tells the crane operator to travel, but to edge the load along by degrees. As the load approaches the first corner, it's rotated by hand to fit through the next passage. Careful alignment of the crane's position is necessary to make sure the unit will travel down the center of the corridor. Slow and easy is the name of this game. Rushing this job could be an expensive proposition, if you consider fingers and toes expensive. Notice that when the load has to change direction, it's brought to a complete stop. But when the crane stops, the load tends to keep on moving. Likewise, when the crane starts up again, the load tends to lag behind. Careful steadying and slow starts and stops keep the load's swing from getting out of hand. In a moment, the load will be set down temporarily, so the hoist and crane can be used to remove the grate from the shaft opening. When setting down the load, Norris signals the crane operator to lower away slowly until the load's just off the floor. Then, very slowly, the load is landed, and the crane releases tension on the slings. Once the load is near the shaft, it's time to remove the grate covering the opening. They'll use the hoist and the crane, and these 2 special slings to lift the grate. This grate's made in 3 sections. Each piece will have to be removed and set to one side before the load can be lowered through the opening. Once all three grates have been lifted from the opening, the hooks are disconnected, and the slings are removed from the load hook of the hoist. The next step is a safety consideration. Norris's helper gets the last two safety cones and puts them in place. So now, the entire work area is surrounded. When the cones are taken care of, the hoist is repositioned, so it's once more over the load. Then the slings can be reattached, and everything's ready to lift the load again. Here's Norris's signal to take up slack. This and all the other signals he uses were worked out with the crane operator in advance. After the slack's taken up, the load is raised so it's just above the floor. Then it can begin to travel over toward the shaft opening. The job goes slow and careful, just as it always should, especially when work's done near an open shaft. As the load gets close to its position, it's adjusted so it can be lowered right down the center of the opening. Norris signals the crane to lower the load, but when it comes abreast of floor level, he tells the crane to stop and slowly lowers the unit through the opening with the chain hoist. Once the load is safely through the opening, the crane can continue the lowering operation. The men on the floor below signal Norris, and he in turn relays the signals to the crane operator. When the load's set down again, it'll be in its new location, ready to be installed. Well, at this point, we've followed a typical rigging job from the start to the finish. We've watched as the job was planned. The equipment was inspected, and the crew was organized. As the job progressed, we saw the rigging mounted on the load and saw the load picked up and moved and lowered. And we learned the signals used to direct the operator of a crane. Whenever you work with rigging, you'll be using these basic skills and procedures and learning more on top of them. Right now, you've got a good basis to learn from, but we've really only scratched the surface. There's still plenty more to learn about rigging. But first, you've got to learn the basics. You've seen a lot of them demonstrated here, and there are more details in your textbook. But with skills like rigging, practical experience is the only way to really get professional. You'll learn the most about rigging by doing it. What you don't want to learn by personal experience is rigging accidents. It's much easier to learn safety from the experiences of others. So remember to count your fingers and toes. A good rigger will keep all of them.